All right, today we're going to talk about finding absolute extrema or global extrema. Up to this point, we've only done relative. So let's take a look at what the candidates test is. First of all, to find extrema, the function must be continuous. Okay, so continuous on the closed interval. You find the critical points on the open interval from A to B. You evaluate those critical numbers, and then you evaluate the endpoints. These two steps are referred to as candidates test. You must have all of the candidates tested in order to receive full credit on a free response. So I'm going to show you how to do that. The least of the values, obviously, is the absolute minimum on the graph, and the greatest would be the absolute maximum. The one thing you want to pay attention to is the question. Sometimes they will say, what is the maximum or minimum value? So in that case, you would be given the y value, or the question may say, where does the maximum or minimum occur? And that would be the x values. So make sure you're answering the question that is being asked. So let's take example here. Find the absolute extrema of this polynomial. So the first thing you do is find the critical numbers. And for this one, since it's a polynomial, that's where the first derivative is going to be equal to 0. So 12x cubed minus 12x squared is the first derivative. We're going to set the first derivative equal to 0. And there are times when you get credit just for knowing that you have to set the first derivative equal to 0. That does happen from time to time. So again, make sure you use your proper notation and show all of your work completely. So the critical points that come out of here, your critical points or your critical values or your critical numbers would be x equals 0 and 1. Okay, so the next thing that you would do is evaluate the critical numbers and the endpoints, and you would evaluate that at f, because that's where the absolute extrema will happen, either the critical points or the endpoints on this function. So what you're going to do is you're going to make a table, and you want to know the y values on the graph because that's what you're trying to optimize here. So again, we're going to put our endpoints. The endpoints are -1 and 2. And yes, they'll look at your table and make sure that your endpoints are being evaluated. And then your critical points will fall in between. So we have 0 and we have 1. Now we're trying to find the absolute extrema. We're trying to find the absolute y value. So we're going to be evaluating these into the function, not into the derivative. Okay? So if we go ahead and we plug in a -1, that's 3 times a -1 to the 4th minus 4 times a -1 cubed. Well, that's going to be positive. And that's going to be a negative times a negative. So we end up with 3 plus 4, which equals 7. Okay. Now when we plug in 0, you're going to get 0 minus 0, which is just 0. When you plug in 1, you'll get 3 minus 4, which is a -1. And when you plug in 2, that's going to be 3 times 16 minus 4 times 27. Oops, no, 4 times 8. Sorry, 4 times 8. Okay, which is 48 minus 32, which totals how much? 16, correct? Okay, so if you're going to have absolute extrema, and you will because it's a closed interval, it's going to occur at one of these 4 values. So again, the least of the values is the absolute min. So which is the smallest y value here? That's this one right here. So you have an absolute min, your absolute min is equal to a -1, and it occurs at x equals 1. So depending on which question, multiple choice, they could want this or they could want this. Free response, it all depends. I would write both just in case. Now how about an absolute max? Which of these numbers is the largest number? This one right here. So your absolute max is equal to 16, and that occurs at x equals 2. So I've got a little graph here of this polynomial between -1 and 2. So let's just go ahead and take a look at 1. Would you agree that that is the absolute minimum on the graph? You're not going to have the graph, but I just wanted to show you that our work does match with the graph. And then over here at x equals 2, would you agree that that is your absolute max? I don't know if I said max here. I meant absolute min. So this is your absolute min. This is your absolute max. So this is a graph. Again, you're not going to be given, but I just wanted to show you that what we did worked. Okay, so let's take a look at the next one. Find the extrema. Okay, again, find the extrema. They are referring to the absolute extrema. When they say find the max or find the min, people will say, well, I didn't know if they wanted the absolute or the relative. If it doesn't say relative, they want the absolute. Okay? So the first thing we need to do is find the first derivative so we can find the critical values. So that would be 2 minus multiply, you get 2x, subtract 1, you get -1/3. Now this one you have to be careful on because that's 2 minus 2 over x to the 1/3. Now you could set this equal to 0 to find where your first derivative is equal to 0. You could also write it as a single fraction, 2x to the 1/3 minus 2 over x to the 1/3. You could write it like that as well. You're going to get the same answer. But what you have to realize is that we have critical values at wherever the first derivative is equal to 0. So if you set this derivative equal to 0, it would be the same thing as setting this numerator equal to 0. Okay, so however you decided to do it, you would get the same answer. So you would end up getting 2x to the 1/3 minus 2 is equal to 0. And that's going to give you what? X to the 1/3 equals 1, which gives you x equals 1. So that is a critical value or critical number. But also don't forget that critical values come when your first derivative is undefined. And what would make our first derivative undefined here? Right, 0. So x equals 0 is also a critical value. So f prime of x is undefined at x equals 0. So all critical values, first derivative equal to 0 and first derivative undefined. So we're going to do the same thing. We're going to make a table. Let's use f of x here. Again, we are trying to find the mins and the maxes of f of x. So you can write f of x, or you can write f of x equals. I like to write down the equation that I am plugging into just to remind myself that I'm not plugging it into the derivative, which is a very common mistake. So you're going to include your endpoints, and your critical values will fall in between. If they don't, then you did something wrong. Okay, so let's go ahead and evaluate. That's going to be 2 times a -1 minus 3 times a -1 to the 2/3. So that's -2. And this is the cube root of -1, which is a -1 squared. So that's going to be a +1 times a -3. So that is going to, and yes, this is non-calculator. So that's going to give you a -5. When we plug in 0, you're going to get 0 minus 0, which is 0. When you plug in a 1, you're going to get 2 minus 3, which will give you a -1. Now let's plug in a 3. 2 times 3 is going to give us a 6, minus 3 times 3 to the 2/3. And that is 6 minus 3 times the cube root of 3 squared. The cube root of 9. Well, the cube root of 9 is close to the cube root of 2. I'm sorry, the cube root of 8. So this is a little bit bigger than 3 times 2. The cube root of 9 is a little bit bigger than the cube root of 8, which is 2. So this is very close to 0, but it's going to be slightly less. Slightly less than 0, just to give you an idea. Slightly less than 0. So yes, again, non-calculator. So where are your extrema? Well, what is your smallest number on here? -5, 0, -1 is something slightly less than 0. Well, this is going to be your absolute min is going to be -5, and it's going to occur at x equals -1. And what is your largest value here? This right. So this is your work. So when you're writing out your answer, make sure that you don't have to explain what you did. This is supporting work. You would just say you have an absolute maximum of 0, which occurs at x equals 0. And you would say you have an absolute minimum of -5, which occurs at -1. Okay, so going over here, I sketched the graph here, and that looks like an absolute max, right? That occurs there, and your absolute min on this graph was right here. So again, our work is correct, and this is the supporting work for your answer. So put it in a table, okay? The next example, you can see what your answers are going to be. I'm going to have you do this one on your own. You should get that as your max, which is 3, and it's going to occur at pi over 2. And then your absolute min is going to be here. I'm not sure if those are the same or not. I don't know. You're going to figure that out. It looks like they're the same y value on here. So I'm going to let you try this one yourself. It is challenging. I'm going to give you a hint. Taking the derivative, don't forget your chain rule on this. And then in order to solve for the first derivative equaling 0, you're going to have to remember your double angle identity. So that's my hint on this one. Don't forget the chain rule when taking the derivative, and when setting the derivative equal to 0, you're going to have to remember the double angle identity for sine. Okay, so go ahead and try that one on your own. And let me do one more. Okay, this is going back to particle motion. You have a particle that's goes along a straight line. This is your s of t or x of t. And you want to find the minimum and maximum velocity of the particle. Now, think about what you're maximizing, or we call this optimization. If you are trying to minimize or maximize velocity, let's go back to this previous page. We were trying to find the absolute min and max of f of x. So we used the first derivative to find our critical values. So think about this one. If you're trying to find the min and max of velocity, what do you think you're going to set equal to 0? Are you going to set velocity equal to 0? Or are you going to set the derivative of velocity equal to 0? And the answer is the derivative of velocity, which is acceleration. So I'm giving you the position. So you are going to, again, use proper notation. They like to see the linkage with the proper notation. The derivative of position is equal to velocity. Okay, so that's 4t cubed, right? And then we have 12t squared plus 12t plus 0. So that's velocity, but again, if we're trying to optimize velocity, we need the derivative of velocity. So again, use the proper notation. The derivative of velocity, also called acceleration, is going to be 12t squared minus 24t plus 12. So the derivative of velocity is what we're going to set equal to 0. And I'm going to go ahead and factor out a 12 so I can make the problem a little bit easier. And then this is a perfect square trinomial and factors into t minus 1 times t minus 1. So this derivative set equal to 0 is going to give me my critical values. 12 never equals 0, but this equals 0 at 1. So now when I go to make my table, my endpoints are 0 and 3. And my critical value here is 1. Now what are we trying to optimize here? We're trying to optimize velocity. I don't want to know what the largest position is. I want to know what the largest velocity is. So we need to evaluate these points or these t values here at velocity. So we need to use 4, and if you want to make it easier for substitution, because again, this is non-calculator, I would rewrite this as 4t, and what do I get when I take out a 4t? I get t squared, right, minus 3t plus 3. That might make it a little bit easier to do substitution. Again, it's completely up to you. So when I plug 0 into t, I'm going to get 0 times anything is 0. When I plug in a 1, I'm going to get 4 times 1 squared minus 3 times 1 plus 3. So that's going to give me a 4. When I plug in a 3, I'm going to get 12 times 3 squared minus 3 times 3 plus 3, which is going to give me a 36. So again, if you didn't factor this out, when you do direct substitution for a 3 in here, the numbers are going to be kind of big. So try to make the problem a little bit easier since it is non-calculator. So these were my critical values that came from the derivative of velocity equaling 0 and the endpoints. Which one is the maximum velocity? You have a maximum velocity of 36 at x equals, or at t equals 3, excuse me, and you have a minimum velocity of 0 at t equals 0. And again, write out the answer. The minimum velocity is what, where. The maximum velocity is what, where. So make sure you write out your sentence on a free response. Don't assume that the AP reader will gather that information. Okay? So I'm going to give you one more problem to do on your own. Find the minimum and maximum acceleration. Minimum and maximum acceleration. So if you're trying to optimize acceleration, where do you get the critical values? Where do you get the critical t values? Think about that, and don't be a jerk.